Okay, let's start with the question number 1 here. We have a crate C is put at a constant speed up a straight inclined path. So there is a path that's inclined. Okay, and on this we have a crate that is being pulled at the angle of 15 degrees to the path here. It is put with the force F. Okay, it is put at a constant speed. Okay, so the velocity NP is the same as velocity in Q here. Okay, this is the point P. Think of them at the bottom, and point Q. Think of them at the top of them. Okay. The distance between P and Q is known to be 100 meters. And we know the work done against resistance, okay, that is 900 joule. The gain in this potential energy, so gain, okay, in PE, potential energy is 2,100 joule. Work done, write down the work done by the pulling forces. So what is work by pulling forces? And hence finds the value of F. Let's do this. Sorry.
What page
This is
that?
page 141. This is chapter 9, page 141. Okay, now let's understand what each of these meaning. If there is work against resistance, this is the energy that we lost because we work against it. Hence, this is going to be the energy that go out from us. The gain in kinetic energy, that will be the same with potential energy at Q minus the potential energy in P. That is what we call by the gain. Okay, now let's write the equation that we know. Kinetic energy in P plus potential energy in Q plus the energy that we input, the same with the kinetic energy in Q. This is in P, sorry. P and P, that's plus potential energy at Q plus energy that we put out. Now, in this case here, we want to find out the work done by the F. Work done by the F is the energy that is given to the object. That's going the same with energy that's being inputted. In this case, because the velocity in P and Q is the same, we can cross them out. They're going to be the same. If they're doing the same, they're going to cancel out. Now, if the gain in potential energy is potential energy Q minus P, hello? We can then simply set the potential energy of P as 0. Think of the P being at the bottom. So the gain is the same with the difference between PQ and PE. PE in Q minus the PE in P. So potential energy and P, we put them as 0. With this, okay, we have the condition energy input is potential energy in Q is 2,100, okay, plus energy out, that is energy for resistance, that's 900. So energy out is 3,000 joule. Up until this, any question?
Sir, I want to ask something.
Yes.
Why is potential energy P 0?
Here, if we want to have the difference between potential energy, it doesn't really matter where is the value of P and Q. What we know here is the difference between them. Hence, for simplicity, we are going to take P as the bottom with the height of 0. Okay, another way of seeing this, I'm going to rewrite this in this form. Energy input is kinetic energy. Kinetic energy at Q minus kinetic energy at P plus potential energy at Q minus potential energy at P plus energy out. Now, this part here is 0 because we know they are the same. If they are the same, when we subtract them, they are going to be canceling out. In this part here, that is the gain in PE. So that is going 0 plus gain in PE, the 2100. And the energy that is lost is the same with energy we use for resistance, 900. Maybe this form is more understandable. What do you think?
Yeah, it's more understandable because energy input equals to kinetic energy Q minus kinetic energy P plus PEQ plus minus PE.
Minus. Yes.
Plus
this is what we
energy
call
out.
the gain. This is what we call the gain in PE.
Oh, okay.
Now we have them here. Okay. We know the work done is the same with the energy that we input them. What people give is what we receive, right? Work done by the force is the energy taken by the object. Now what about the force? In this case, because the force is not parallel to the distance, to the direction of motion, moving here, we use the formula that energy is force times distance times the cosine of the angle between them. We are asked about finding the force, right? So that's going to be the energy divided by the S times cos theta. So it's going to be 3000 divided by 100 times cos 15 degree. Okay. Okay. Can I ask, today the morning devotion is by Sharon, right? So the task of answering questions, we start from Brandon. Brandon, calculate me this. Okay. Next question, I'm going to ask Caroline, and next again is going to be Fiona, as usual. So Brandon, get me what is the value. What is this?
31.058.
Okay. Now, in the final answer, we will have them in 3 significant figures. So that's going to be 31.1 in the final answer. Okay, that is the first question. Is there any question here? By the end of this lesson, I'm going to give you a task of solving this question. So there's 2 possibilities. You can try to write this down as we have the lesson, and after that you simply take the picture of your notes and post in your e-learning, or you can try to understand this first, and after the lesson rewrite what you understand, maybe make them simpler or neat or somebody any other way, and post that for your e-learning. I repeat, on the second period today, your task will be submitting the questions that we discussed, which is questions number 1, 2, 3, and 5, 4 questions. There are 2 ways you can do that. You can write down as we are working this, or you can try to understand this first, and after that, rewrite the question, rewrite the answer, and submit.
Sorry, it's 1 to what?
1, 2, 3, 5. We skip number 4. Okay, any question for the first question here? No? Okay. No more question. I'm going to go to question number 2. Okay. A load of mass 1 to 50 is raised by a crane. So let's have them here. The mass is 1 to 50. Okay. From rest. So the initial value, initial velocity is 0, meter per second. Okay. On horizontal ground, as horizontal, that means that the height initially is going to be 0 meter. Okay. To rest, okay, so the final velocity is still also 0 meter per second. At the height of 1.54, that's going to be height number 2, 1.54 meter, okay, above the ground. The work done against the resistance, that's going to be, work resistance, that's the same with the energy that is lost or energy out. Okay. Up to you. You can call them energy in or energy out. I'm going to make them energy out. Okay. That's going to be 5750 joule. Question. First, what is the work done by crane? Work crane will be the same with energy that is we receive. The crane gives energy, and that is released by the body. The second, assuming that the power is constant, the power is 1 to 50 watt. Okay. What is the time taken to do this? Okay, let's do this again, step by step. Start by writing the usual equation. KE1 plus PE1 plus energy in is KE2 plus PE2 plus energy out. In this case, the kinetic energy 1 is 0 because initial velocity is 0, so it's 0. PE1 is 0 because the height is 0. And the energy input is the one that we want to find out. Kinetic energy 2 is 0 because we know that the final velocity is 0. It says from rest to rest. So on the top is also resting. At potential energy 2, we need to calculate them. That's going to be mass times gravity. The gravity stands for mechanics, okay, unless otherwise stated. Okay, times the height is 1.54. Plus the energy out is the same with the work against the resistance. That's going to be 5750. So energy input is, okay, Caroline, get me this. Caroline, hello. Are you there?
Yes, yes.
Sorry?
Yes. 25,000.
25,000. Okay, and then? Is that whole number? Is that whole number?
Yeah.
Okay, 25,000. Okay, good. Now, next, how do we find the time? We know that the energy is power times time, right? If it is the time that you want to find out, then time becomes energy divided by the power. So that's going to be 25,000 divided by 1 to 50. That simply become 20. So time is 20 seconds.
Sure. Power is the mass.
Power, no. Power, okay, is energy divided by time. Energy per time. That's what we call power.
So why the Power is the same as the mass.
Oh, I don't know. It is given here on question number 2 here. The power is 1.25 kilowatt. I think it's just coincidence here.
Oh, coincidence, yeah.
Yeah. It's not because it's not the same here. It's just coincidence that it is 1.25 kilowatt, and I'm changing that into the watt. Okay, that is question number 2. Any question here? I think you already find out that even in the past papers, the question is pretty much simple, as long as we understand what was meant by the question. By far, the problem in mechanics is understanding what the question is. That is more than half of the problem. The answering themselves is normally simple and straightforward, as you see them here. I'm going to go to question number 3 if you've done, guys.
Wait, sir, wait.
You can also do screenshots if you want to make them fast.
After this, we can take a photo of the notes, right? And then send it to you?
Yes, yes.
Okay.
Send them to e-learning, not to me. I'll take them from the e-learning later.
Oh, okay. But it's still sent to you, right? Through e-learning.
Yeah. Yeah.
Sir, what's the due time? The
Sorry?
due time. I mean the due
The-
time. To
4 p.m. as usual. All tasks has the due date of 4 p.m.
Here's the problem with that, sir.
Sorry?
Here's the problem with that. Like some
Mhm.
teachers,
Yes.
I'm not gonna name names because that's not polite. But some teachers are like really keen on it. Like, it has to be done on time.
Mhm.
But then, like, sometimes different people have different speeds in writing. Some are faster than others. So some teachers like wouldn't really accept if you don't submit it after time, like handwritten. So that's the issue. I'm not gonna name names because that's not good. But,
Well, yeah, there are several. There are different ways of teaching, okay, for different subjects. I think. Let's just learn to be adaptive. Okay, Dan, can I go to the next question?
yes, you may, but ask the girls first.
Yeah. I'm waiting for Patricia. You done, Patricia?
yes, sir.
Okay. If you just want to get them here, my suggestion will be just to capture them. That's going to make it fast for all of us. Now, we go to question number 3. Here, we have a drum that is going to take an object from the ground. Initially, it is here, and that's going down here. This is position O, and this is position A. The distance between A and O is 20 meters. Now, it's given here from rest, so the velocity at O is 0. Velocity at A is now known as 1.25. The mass given as 160 kilogram here. Now, we can calculate them here. Question here. First, what is the gain in potential energy? What is the gain in potential energy? If you have the gain, means what is after minus before. So it's going to be potential energy in A minus the potential energy at O. That's going to be mass times gravity times height on A minus mass times gravity times height at O. Because the height at O is 0, so we just need to calculate this. It's going to be 160 times 10 times 1 point, times 20, sorry. Times 20. Okay. That's going 32000. I repeat, gain means what is after minus what is before. if you want to find out what is your gain in gain as if profit. Okay. Profit is what is the price after minus the price before. If you want to gain in stock exchange, what is the price of your stock now minus the price of your stock before. Next, what is the gain in kinetic energy? That's the same here. That's going to be kinetic energy in A minus kinetic energy at O. That's going to be half times mass times velocity at A square minus half times mass times velocity at O square. Because we know the velocity at O is 0, they are at rest here, we just need to calculate the first part. So it's going to be half times 80 times 1.25 square. Now, Fiona, what is this then? Fiona? Are you there?
Yes, sir.
Mm-hmm.
62.5.
62.5.
5.
Okay. Next, okay. The power of the winding drum is constant while the rod is in motion. Part 3 now. Given that the work done against the motion from O to is 20 kilojoule, that is going to be the same with the energy that we are going out. Work against resistance is the same with energy that we given out. That's going to be 20,000. And the time taken is 41.7. Time is 41.7 seconds. Find the power output of the winding drum. So from here, we can calculate the energy input first. I'm going to write the modified equations. Energy input is the kinetic energy 2 minus kinetic energy 1, okay, plus potential energy 2 minus potential energy 1, plus the energy that we lost. Why? Because this is the answer first here, 32,000. And the second here is the energy we calculate here, 6.5. And this one here is the energy out, 20,000. Oh, my bad. The mass is 160. My bad. Okay. So that's going to be 125, right? Am I correct?
Yes.
Yes, 125.
Okay. So, Kezia, what's the total then? Kezia?
23,325.
Sorry, can you repeat the number by number?
23,325.
Why? Why 2, 3?
This one, right?
Yeah.
Wait. Oh, wrong. I less. Wait. Needs more zero. 52125.
Oh, 52125. Okay. Now we know, just like the previous one, okay, because we know that power is energy per time. So that's going to be that number 52125 divided by 41.7. Jane, what is this? Jane, are you there?
Yes.
Get me the result then.
One to 50.
1 to 50.
Is it
The
in
unit
joules, sir?
is, no, it's power, it's watt.
Huh? Is what?
It's power. Power has the unit of watt.
Oh, W. Okay. Sir, if you want to continue to question number 5, I think we have to extend the Zoom a little bit there.
Okay. So that's it. I'm going to erase this if anybody still take note. For simplicity, for us to keep the time, I think just take a screenshot. Okay, and then you can read them at your convenience afterwards. Okay, I'm going to erase them now.
Ah, anjing.
Who?
Oh,
What's up,
sorry.
Patricia?
Pat, don't worry. I take all the notes down, so you can actually, I can photo it for you.
Okay. Accidentally.
Yeah, it's fine. So because like shock kan ka. Woo!
Yeah,
Sir,
you
you have to, extend the time, sir. You have to extend the Zoom.
Yeah. Okay.
Can we go and then
Let's-
every one of us?
Yeah. Okay. Please go back again.